basic understanding of these three items. So I just want to give you intuition to what these are. So when you're studying fluids, so maybe fluid dynamics, you have a concept of what these might be, kind of in simpler terms. I will also put references back in the description, okay, so that you can get a little bit more if you wanted to. So first, let's jump into viscosity. So with regards to viscosity, so what exactly is this viscosity? So here, okay, so let me just point out. So viscosity is basically the resistance, okay, to flow of a fluid. Now, this is kind of important, and the word which is key in here, okay, is this word which is resistance, right, to the actual flow that you might have. And of course, it is within a fluid, so maybe some kind of a gas or a liquid. So that's one way of thinking about viscosity. So it has something to do, so resistance, you might think about is some kind of relation with regards to forces, all right? Now, another item, okay, that you can think about, it is also resistance to deforming a fluid. Okay, so it's sometimes, you know, more difficult, okay, to deform one particular fluid, okay, with regards to another. And I'll give you some examples. So it is resisting the actual flow of a fluid or possibly the deformation of a fluid. So some fluids, for example, like water, you can deform pretty easily, okay, in order to do that. But something like, for example, honey, okay, it's going to be a lot harder to try to actually deform, okay, and that has to do with viscosity. One is lower viscosity, okay, another one is higher viscosity. So the other things to think about, if it is some kind of a resistance to flow and deformation, then you might think about it has something to do, okay, with some particular stronger bonds that are related within that particular fluid for whatever reason it might be. So this is sometimes referred to as stickiness, right? So again, so if you think of a syrup, okay, like maybe honey, okay, or maybe maple syrup, it might seem that they have extremely stronger bonds, right? It's not very easy, okay, to be able to allow these things, okay, to flow. So there is quite a bit of resistance to that, okay? It's a lot harder to actually deform, okay, something like honey, right, or maple syrup. And therefore, there's quite a bit of stickiness. Now, that stickiness isn't just between the actual kind of fluid particles themselves, but it's also possibly between the stickiness of that fluid and another item. So if it's flowing through a tube, which we're very much interested in fluid dynamics, right? So the flow through tubes, right? So those regions that are actually touching the tube themselves, you know, they might be extremely sticky and very difficult to try to flow through. Now, with that stickiness idea, okay, this also kind of brings us back to thickness, right? So how thick is it? And again, so, you know, there's various scales of this, right? So if you're thinking about water, not very sticky, right? Very easily to be able to deform water, right? It doesn't have a lot of resistance, right, as it flows through. And that's why one of the reasons is water is such a special, okay, particular item for us with regards to fluids. But if you're talking about syrups in general, well, they're pretty sticky, okay? And they're, you know, very thick at times, okay, that you might have. So this is all about viscosity. So when you're thinking about viscosity, you indeed can think about, if you want just a little intuition, water, okay, is not, okay, an actual fluid which is high on viscosity, okay? It's actually very low. Something like a maple, okay, syrup, oil even, okay, which might be more, okay, in terms of, or a higher range of viscosity that we have, okay, so that is on the higher scale. So the more resistance that it will have. Now, in general, for us, if we're talking about fluids and the flow, then this is really the ideal case in terms of like thinking about viscosity, which is the resistance, okay, to flow of a fluid. You know, so how hard is it to actually make this fluid flow? And that is viscosity. And again, on the lower range, you know, you can think gases definitely have a lot less, okay? You know, if you're talking about liquids, water will have a lot less, okay, than something like a syrup. Okay, so those are kind of, syrup is very high viscosity, water is much lower viscosity, right? And then we have coefficients which are related towards that. But I don't want to touch on that within here because I just want you to understand this particular term. Now, what about laminar flow? Okay, so this is the second item, okay, that we have here on the list. So how does this relate? And then of course, it must be related to viscosity in some way. Well, it is indeed related to viscosity, right? So I'm going to try my best, okay, to explain this laminar flow. There's certainly, certain ways, okay, textbooks and videos that might, okay, do even a better justice than this. But let's imagine, okay, that we have some kind of a fluid, okay, and it is flowing. And that particular fluid, as we have it, okay, or as we know it, okay, will flow, okay, let's say in this particular direction. Now, laminar, okay, so the word laminar has something to do with layers. Now, flow, we have a concept of that it's actually moving forward, okay, one over the other, so the particles are kind of shifting along. And this laminar flow, if you have, okay, so this particular fluid in this, let's say this tube, as it's flowing through, we can almost think like there's some layers. And what we typically might think, we might think that, oh, you know what, these particular fluids, right? So they're kind of flowing in exactly the same rate, okay, everywhere that they are, right? And they're just moving along. And this is typically something, okay, that you think about in terms of fluids. On average, sure, we can have this indeed, but this is actually not what really happens. What really happens is that, the ones which are in the middle, okay, which are further away from the tube, will flow much faster, okay, than the layers, okay, that are actually a little bit closer to the tube itself, right? Until eventually, actually, the ones which are very close to the tube, okay, are not flowing very fast at all, right? So these guys are really slowed down. And that is to do, okay, with the interconnection between the tube itself, and this is the stickiness, okay, depending on the viscosity of that fluid, right? So, how much is it? And now what happens here, it's almost like you have some kind of a gradient, right? You have a change where you have on the initial side, okay, so within here, so actually right by this, okay, so this is practically flowing at 0 speed. And then it starts to pick up speed, and these layers, okay, up above there, they're going to be flowing at a much faster speed. Now, what does this have to do with laminar flow? Well, laminar means that we have some kind of layers. So you can see that these layers, these gradual layers, okay, are flowing through. Ones are faster than the others. And laminar means that there is really not a lot of interaction between these layers. Now, are these layers real? Okay, yes, they do happen, but there is some overlap in between them sometimes. Okay, and what you can think about the actual fluids is that, if you could, you can find this imaginary paths, okay, where these fluids are almost flowing like in little sub-tubes, okay, all the way along. And these are the layers, so this is why we call this laminar. And there is not much interaction, okay, between this particular layer and then this particular layer over here, and then this particular layer over here. So this is the laminar flow, so the layered flow between the fluid, right, as it goes along, okay, between one layer and another. And within a tube, it's very nice to be able to see. Sometimes you can think of it even in terms of a river, right? So on the edges of the river, right here, okay, you don't really see much of a flow within here of the river, right? It's basically static. But yet in here, it can be torpedoing through, okay, extremely quickly. And that is because the layers, okay, as they're going through there, there's obviously quite a lot that happens within a river. But let's say if it's a nice calm river, nothing really happens, like almost a tube. So you have these layered like flows that are going through here. And this is really what happens, okay, as you have a fluid which is going to be flowing. Now, where does viscosity come into play here? So if you have an actual fluid which is high on viscosity, so there's a lot of stickiness, a lot of thickness, a lot of resistance to flow, okay, you actually are going to have these layers forming, okay, quite a bit. If you took honey and you start kind of pouring it out, you notice that it's almost like they form these layers, right? So they'll flow one and then another layer will flow another, and you can literally almost see those layers forming. That is the laminar flow, okay, of an actual fluid. And you are able to actually see that, okay, if the viscosity is really high. In water, you don't see it. You just pour it because there's not a lot of thickness, there's not a lot of stickiness, viscosity is very low, so it's very difficult for you to see that. It just will take the shape of whatever container that you have very, very quickly, okay, because viscosity is way down. And if you can imagine, if you're flowing through an actual tube, it's much easier for the water to flow. You would need quite a lot of actual forces and pressures, okay, to get something like honey, okay, flowing through, okay, and then pushing it along, okay. Most likely it would be still at a very slow pace. So now, within those layers, this is where actually turbulence comes in, because when you're thinking about this, so as you're going through, so if you have viscosity, you have laminar flow. So laminar flow is this nice flow, and there's really no interaction between the layers. The layers are just kind of nicely flowing through. But you can imagine if you took this, right, and if this fluid was flowing in here, and let's say, there was some kind, okay, some kind of a path like this. Well, then what's going to happen is that you're going to have these particular, layers, okay, so this is going to be flowing, but eventually it's going to hit right here, and it's going to start to create chaos, right? It's going to bounce back off, and obviously it will start to impact, and it's going to be impacting this layer, okay, and this layer, because the actual turbulence that is created in here is now the overlapping of layers. And then what you do start having, okay, is you start having kind of chaotic, okay, interaction between the fluid, and that is called turbulence that you see. That turbulence, sometimes is referred to as kind of like you see these swirls, okay, within the fluid, and we see that. So the referencing back of a river, which is kind of a chaotic river, you see quite a lot of turbulence that is going on, that's hitting rocks at the bottom or on the side or in the middle, right? And then the actual fluids, the layers, so that laminar flow is interrupted, right? And then you have, okay, this turbulence which happens throughout. So that is all that I kind of wanted to be able to say. So in terms of summarizing these, viscosity, okay, is really the resistance to flow of a fluid, right? Water, not very high on viscosity, okay? Something like syrup, okay, is very high on viscosity in comparison to water, of course, right? So that's viscosity. Laminar flow is this nice flow that is created, and then there's almost no interaction between kind of these layers that are forming within a fluid, okay, as they flow through, whichever way that they're going. Okay, and turbulence is when there's now huge chaotic interaction in between, and it can be caused for many different reasons. It doesn't necessarily have to be, something abrupt like I have here, like a clog, okay, within a tube or something of that nature. Okay, but when that turbulence happens, okay, so there's kind of, you can imagine that now there's chaos within the flow of the actual fluid itself. All right, so that is it. I hope this gives you some kind of an intuition, okay, for the three terms. Thanks for watching. We'll see you in a future video. Bye, everybody.